Welcome to this Paper 3 preparation video for GCSE Higher Maths in 2026. As with the other videos, I've tried to put as much content in here as I can based on what we've seen before and based on what potentially could come up. This one's slightly shorter, it's only an hour and a half, so I hope you find it useful. Again, if you want to watch it a little bit quicker, watch it on 1.5 times or 2 times speed, or skip forward to the topics you need. Again, have your calculator ready, have a piece of paper and a pen ready so you can try some of the questions as well. And as always, the best of luck in your exam. As with the previous two videos, just a quick disclaimer that not all the topics that are shown on this are definitely going to come up in paper 3. This is based on, again, the common topics on GCSE Maths papers, but also taking into consideration what's already appeared on paper 1 and paper 2. And this should form part of your revision and should help you in those final few moments preparing for your exam. As with the previous video, paper 3 is a calculator paper, therefore we're going to focus on using the Casio calculators, particularly focusing on the middle one and the one on the right hand side, and showing you kind of where those key functions are that you can use to support you in your exam. One thing also that's important to consider that I forgot to mention in the paper 2 videos, obviously across all of these papers you have got a formula sheet that can help you with this. So I'll just show you what appears in the formula sheet, and this is the same for Edexcel or AQA. So you can see the first one is in the top left hand position. You've got some area, perimeter and volume formulae, which is the area of a trapezium, the volume of a prism, and then the circumference and area of a circle. Top right you have the quadratic formula. So you've got those two formulas at hand. You've also got your Pythagoras theorem and trigonometry. So here you've got Pythagoras theorem, your trigonometric ratios, or SOHCAHTOA as most people remember it. You've also got the sine rule, the cosine rule, and the area of a triangle formula. And we'll do a couple of examples of those questions a little bit later in the video. And finally at the bottom you've got a formula for compound interest, which again some people don't use very regularly, and I'll show you an alternate method to do it. And finally the probability functions. If you've seen those before, you'll know how they work. If you haven't, don't worry too much. They're not used as prevalently as you might think. So the first topic, as with the last video, is using a calculator, and I encourage you just to pause, try and put this into your calculator, make sure that you get the same answer. So the answer on the left hand side is 19.621495551. Again, the thing to be careful with is here. Make sure that you take that bit out from under the square root so that the calculation is correct. Second was a mixed number. Now putting mixed numbers onto your calculator, there's two buttons that you can use. If you press Shift and then your fraction button on this calculator, or in this case Shift and then your fraction button, it gives you a mixed number, which will be it'll look like this on your calculator display, and then you can put the values in correctly. And if you put those in, you get 9 and 36 over 143. Now that's not normally what it is. It'll normally give it to you as an improper fraction, and to change that you do format and then mixed number, or in this calculator you press Shift and then SD, and that will convert it to a mixed number for you. Again, just a quick reminder to make sure that we remember how to round our values. So rounding this to 1 decimal place. Okay, so that's our first decimal place. The 5 rounds the 0 up, so we get 4.1. 3 decimal places for part B. So again, 1, 2, 3 decimal places. Now the 8 is going to round the 9 up, so you're going to end up double rounding here, which ends up with 4.606. And because it asks for 3 decimal places, you must have 3 decimal places. And that happens because that 8 rounds the 9 up, the 9 becomes a 10, which then rounds the 5 up to a 6. Significant figures are slightly different. You start on the very left hand side, so in this case it's rounding to this, so that's just simply going to be 4. 2 significant figures is 2 consecutive values, so again that's just going to be the same as 1 decimal place, so 4.1. And then finally to truncate just means to cut, so you go 2 decimal places and just cut, and that gives you 4.05. Even though we know that would round to 4.06, truncate just means to cut, and don't worry about rounding. Again, just a reminder about HCF and LCM. So what we can do in this case is if we write this value as a fraction, smaller value over bigger value, if we put that into our calculator, it will simplify for us and give us 28 over 45. And then for the highest common factor, you can just do 168 divided by 28, and that gives us 6. Or for the lowest common multiple, we cross multiply, so 168 multiplied by 45, and that gives us 7,560. Now there is a way to do this on your calculator, particularly only these newer models. If you press Catalog, so this button here, and then you're looking for the numeric calculations, and in there you'll see two values, GCD, which is the same as highest common factor, and LCM, which obviously we know is lowest common multiple. And in there you'll put your two numbers in separated by a comma. Now to find a comma, you'll press Shift and then right bracket, and that will put a comma between them. So your calculator might have something like this: GCD bracket 168, comma 270 bracket. And then when you press equals, it gives you an answer of 6. And if you change this GCD to LCM, it'll give you the same answer. So that's just a feature of the newer calculators that's could be helpful in this situation. The next topic is product of primes, and obviously your calculator will do this work for you. You don't need to draw the tree on calculator paper. So again, the answer you should get if you do this on your calculator is 2 squared times 5 times 19 times 43. And that's your product of prime factors. Now how you do that is on your calculator, you put the number in, so 16345, and then press equals or exe, so it becomes your answer. On this left hand model, you just go to format and then find prime factor, and that will give you the answer you need. On the older model, you can just press Shift, and then this button here, you can see it's got fact written above it. So this degrees and then 3 apostrophes. If you press Shift and then that button after you've put that number as your answer, it will give you your prime factorization of 2 squared times 5 times 19 times 43. Now again, the next work we're doing is just fractions. And very simply, just remember that of means multiply. So in this case, you just put this into your calculator, 15 over 37 times 22,674, and your calculator does all the work for you. It wants our answer to 2 decimal places, so that will give us 9,192.16. The second one, writing one quantity as a fraction of another, so 52 hours. The first thing we need to do is convert this 3 days into hours. So 3 times 24, because it's 24 hours in a day, is 72. And then we just get 52 over 72. Put that into our calculator, and that will simplify to 13 over 18. This one, we're given a number or a fraction, we're told that's the number. This is what I would call reverse fractions. And similar to reverse percentages, you just divide by the fraction. So you get 3675 divided by 5 over 19, and that's not a problem because your calculator will do all the work for you. You don't need to write down that as keep, change, flip or anything like that. Just put it into your calculator, it gives you 13,965 as your answer. And then finally, writing this number as a decimal, truncated to 3 decimal places. So again, remember truncate just means to cut, so you just write down 0.363. Doesn't matter what comes after that, it just cuts after 363, and that's it. And again, that's just putting it into your calculator and converting it to a decimal in the usual way. Recurring decimals again doesn't seem to have come up yet, so it's quite a useful one to just make sure that we're practicing. So we've got x is equal to 0.61, and then the 3 is recurring. Remember, our first equation is for our non-recurring pattern, so that's 2 decimal places long. So that means we've got 100x is equal to 61.3 recurring. That's equation 1. And equation 2 is the full length, which is 3 decimal places, which is 1000x equals 613.3 recurring. We subtract those two equations from each other, and we get 900x is equal to 552. Solving then, that gives you x equals 552 over 900. And then you can just simplify that on your calculator by putting that value in, press equals, and that gives you 46 over 75, which is the answer they wanted you to show that it was. Again, high feature of a calculator paper is going to be your work on percentages. So again, finding a percentage of an amount, in this case you just do 5132 multiplied by, and we're going to work on our multiplier, which in this case is 0.436, so just dividing by 100, so 0.436, and that gives you an answer of 2237.55 to 2 decimal places. We'll do the one on the bottom left now. So it says Cassim buys footballs for £7.50, he sells them for £11.99. Work out his percentage profit. So that's profit over cost as a fraction, and then again to convert to a percentage, you just times by 100. So that becomes, he's making $4.49 profit per football, and he buys them for $7.50, multiply by 100, and we're going to work out our percentage profit, which is going to be, to one decimal place, 59.9%. Finally, this one on the right hand side, it says, I increase a number by 48% and then decrease my result by 48%. Will I return to my original number? Explain your answer. Now you're not given a quantity, so you've got two options here. You can either pick a quantity, increase it by 48%, then decrease the result by 48% and see if it brings you back to your original value, or you can just use multipliers. A 48% increase is a multiplier of 1.48, and 48% decrease is a multiplier of 0.52. Again, 100 plus 48 divided by 100 and 100 minus 48 divided by 100. If we multiply those two values, 1.48 multiplied by 0.52, that gives us an answer of 0.7696, which means that at the end we have 76.96% of our original number. So therefore the answer is no, we will not return to our original number. We'll be significantly lower. Okay, we'll be nearly 25% lower than we were when we started. The other option, which you might find easier to understand, is pick a number. Just say, if I use 100, or if I use 1,000, or if I use 200, whatever number you want to pick, decrease it by 48%, then increase the answer by 48%. Again, using your multipliers, you'll show that you won't end up in the same position. Again, in this case, we've looked and we said the population has fallen by 13.2% since 2006, and it gives us today's population, asks us to work out back in time. So this, like our reverse fractions, is a reverse percentage. So therefore we're going to find our multiplier. Fallen is a decrease, so that means our multiplier is 0.868. 100 take away 13.2 and then divided by 100. And then because we're going back in time, we're going to divide by our multiplier. So we divide by 0.868, and that will give us an answer of 400,000. So the population was originally 400,000. Next one is about compound interest and repeated percentage change, and they give you these options where it's like, oh, which one is the best deal? What I like to do is split the page in three, and I'm just going to work underneath each of those cards. So it says Saver is 1.9% interest per year, and I'm investing £5,000 for 6 years. So we're going £5,000 as a multiplier. That's 1.019. Again, adding to 100 divided by 100. Multiply by 1.019 to the power of 6. And that gives me an answer of 5,597.77. Now I've rounded that to 2 decimal places because it's money. Money should be rounded to 2 decimal places or 0 decimal places. It can't be anything else other than that. For the plus account, because we've got two different interest rates, we start with 5,000 multiplied by our first interest rate, again to the power of 1. And then we can, in the same sense, multiply by the second multiplier for the remaining 5 years. Okay, and again we can put that all into our calculator in one go, and that gives us an answer of 5,472.50. So you can see currently the Saver Basic is the better option. Finally, the Saver Ultimate, we've got 3.3% interest every 2 years. So we'll talk about that in a minute. So we get £5,000 multiplied by our multiplier, 1.033. And instead of being to the power of 6 for 6 years, because it's every 2 years, that only happens 3 times. So be careful that you get that number right. So it's how many times we do that. And that gives us an answer of £5,511.51. So then the answer, which is the best deal, is the Saver Basic, because it gives us the most amount of money at the end. And the final question on percentages is just on percentage change. So again, remember we do change over original times 100. So therefore in this case the change is the difference between 2,430 and 2,911, which is 481, over the original value of 2,430 times 100, which when you put in your calculator gives you 19.8% to 1 decimal place. Now Best Buy is the next topic that we're going to look at. And they can ask this in one of two ways. They can either ask you to work out which deal is the best value for money, or they can ask you something like this where it asks you to work out the best way to buy a certain number of bottles, so in this case 8 bottles. In either way, we're going to start by finding the unit price for each one. So for the single bottle, we already have the unit price, which is £3.50. For the 4 bottles, we're going to do £15 divided by 4, and that gives us £3.75. So this is £3.75 per bottle. And then the last one is 20 divided by 6, which is 3.3 recurring. So therefore in money is £3.33 per bottle. So we can see the best value for money is obviously the 6 bottles, followed by the single bottle, then by the 4 bottles. Now we're going to use this then to decide how do we buy our 8 bottles. We want to buy exactly 8 bottles, so therefore we're going to buy 1 6-pack and 2 by singles. And the reason we're going to do that is because the best value for money is this 6-pack, followed by the single bottle. This is the worst value for money, which is why we don't use any of those. And that's the best way to buy 8. If then was to ask us, well, how much would those 8 bottles cost us? Well, we would just do 6-pack, which is £20, 2 singles, which is £7. So therefore we pay a total of £27 for our 8 bottles. Next topic is currency conversion, and remember in currency conversion it's always going to be in the form pounds is equal to the other currency, and if you're changing from pounds to the other currency you multiply. If you're changing from the other currency back to pounds, you divide. Now one thing I should have mentioned is it will usually, again it should always be in the form £1 is to something else, because that 1 unit is always based on your home currency, and obviously in the UK we use pounds, so it should always be £1 is equal to something, like we can see in this question. So we're going to start with the original £800, and we're going to convert that to euro using the exchange rate that Reese got, which is multiplied by 1.32, and that gives us €1,056. It then says he gets sent the same amount of euro back, so that's the €1,056, but the exchange rate has changed to 135. So we divide that then by 1.35, and that will give us an answer of £782.22. And the question was, does he receive more or less from his brother? He receives less back. Because of that change in exchange rate, he's lost about £18 on that. Next one is combining ratios. So we've got D, E, and F. So we're going to write that just as one single ratio. So D to E to F. First of all, let's line up D to E, which is 11 to 5. And then we're going to line up E to F, which is 9 to 4. And because we know both of these, we want to make those the same number. Their lowest common multiple we can get by just multiplying them. So 4 times 9 is 45. That means we've multiplied the first line by 9 and the second line by 5. And that gives us 99 and 20. Now the question asks for DF as a ratio in its simplest form. So DF is then 99 to 20. Now to check if that can be simplified, we can just put that in our calculator, which is 20 over 99. And if we press equals as a fraction, it will give us 20 over 99, which means it can't be simplified. So this is our final answer. Now the next question we'll look at is these algebraic ratios, which can sometimes appear on the paper. So if you're given a ratio is equal to another ratio, we're going to write that as a fraction first. So A came first, so we'll put A on top over B. And then in the same sense in the second one, 6 comes first, so we'll put that on top over 13. To get our equation, then we're going to cross multiply first, which gives us 13A is equal to 6B. Now once you write an equation for B in terms of A, that means get B on its own. Okay, so therefore we're going to divide both sides by 6 to get B on its own, and we get B is equal to 13A over 6. And that's our ratio for B. That's our equation, should I say, of B in terms of A. Now proportion, again, this may have already appeared, but you might get elements of this in there. This is where you get those 3 parts. So we've got 3 elements to look at. We've got teachers, we've got hours, and we've got papers. Now we always put time in the middle because that's the one that kind of varies things for us. So if we fill this in, the relationship here on the left hand side is inversely proportional, because if I have more teachers, it'll take less hours. If I have less teachers, it'll take more hours. Where the number of hours is going to be directly proportional to the number of papers, because if I have more work to do, then it'll take more hours. So filling in the original values, we get 9 teachers, 2 hours, 306 exam papers. Now we're always going to change one of the values based on the information we have, and we're going to keep one of the values the same. And hours tends to be the one that's always going to be included in that change. So in the first case, we're going to keep the teachers the same, and we're going to increase our papers to 2448. Now, to get from there to there, we just do 2448 over 306. Now, if you stick that in your calculator, we'll just give you 8, so you're essentially just multiplying by 8. So therefore that gives you 16 hours. But again, you don't need to work out that 8, you can just do 2 times that fraction, and that will give you your 16. So now the papers are finished, and we can just keep the papers the same for the rest of this. And it'll take us 2 more rows. The next thing we're going to do is we're going to figure out 1 hour. So how long will it take? Actually, let's do it a different way. Let's do it as 1 teacher. So if we have 1 teacher, how long will it take? Well, in that case, we divide this by 9. So therefore here we're going to multiply by 9. And that gives us 144 hours it's going to take us. Now we want to know what would happen if we had 20 teachers. So to get from there to there, we multiply by 20. So in this case, we divide by 20. And 144 divided by 20 gives you 7.2 hours. Now to the nearest minute, that's 7 hours. And then 0.2 hours. If you put that in your calculator, 0.2 times 60, which gives you 12 minutes. So it's going to take us 7 hours, 12 minutes. And that's the answer for this one. Now you could have done it in one step here by saying, well, in this case, to get from there to there, I'm multiplying by 20 over 9. So in this case here, I'm just dividing by 20 over 9, and that will get you there in one go. Now standard form, the only thing you really need to be able to do on a calculator paper for standard form is convert to and from between standard and ordinary form. The rest of it you can just do in your calculator. And actually most of the time you can convert from standard form to ordinary form in your calculator. If you type exactly this into your calculator, it will give you an answer of 5976200 or 5,976,200. So that gives most of it. It just has to put in standard form. Great, so in standard form that's 5.9762 times 10 to the power of 1, 2, 3, 4, 5, 6 times 10 to the power 6. And that's our answer in standard form. And again, our calculator will do most of the work. The only thing you might have to do, as I said, is convert between those two, because your calculator might leave it in standard form or leave it in ordinary form, and you then have to convert it the other way. Now looking at bounds, again, this may have already appeared, but it's just making sure that we're fully clear on this. So this first one has to round to 2 significant figures. Now the second significant figure is this one. So essentially this is just the same as saying the nearest 10, because the second significant figure is in the tens column. And I would recommend that you convert it like that, and then go, okay, well 320 goes in the middle, 10 more than that is 330, 10 less than that is 310. So your upper and lower bounds are 315 and 325. So therefore your lower bound 315, upper bound 325. And if you were asked to write as an error interval, it would be 315 is less than or equal to x is less than 325, remembering your symbols. For discrete values, remember, there is a maximum and minimum value. So if we draw the same idea here, 75, 5 below that because it was the nearest 5, 5 above that is 80. So my halfway marks are 72.5 and 77.5. Now what we have to remember is that this is people. You can't have a decimal number of people. So therefore the numbers that round to 75 are in between these two values. So the minimum in this case is 73 and the maximum is 77, because that's the smallest integer and the largest integer within that range. If you were in a case where this was an integer value, so let's say it was 78, you'd have to use the value before, and the reason you have to use the value before is because that number there will technically round up, so you have to use the number before that. With this one, you can use the lower bound, that's fine. For discrete values, the upper bound, you must subtract 1. And again, it depends on the context. If it's in money, you subtract a pound. If it's people or things, you just subtract 1 whole. Now the next one is balance calculations, and I've shown this table before. Again, that's just a reminder of what we need to do in each of these questions, and this should be in your head. So it says a bridge can hold a maximum mass of 30,000 kilograms. Okay, so that's not rounded, it hasn't set it around, so that value is fixed. So that value stays like that. It says the mass of a car is 1,000 kilograms to the nearest 1,000. So therefore, if we look at this, 1,000 is what we have in the middle. 1,000 below that is 0. 1,000 above that is 2,000. So that means your cars are anywhere between 500 kg and 1,500 kg. Now it asks for the maximum number of cars that can cross the bridge at the same time safely. So in this case, we want to think worst case scenario. Now the worst case scenario is that the cars are as heavy as possible. So we're going to assume that all the cars weigh this. So therefore we're going to do 30,000 divided by 1,500. And again, we can do that using our standard method, or we have a calculator anyway to make our life easier, but that's 20 cars. Now in reality, there might be more. It might manage 21 or 22 depending on the value we use, because if we'd used the lower bounds, we would have ended up actually being able to have 60 cars. Okay, but to be definite, we want to think worst case scenario, so the most number of cars, which in this case is 20 cars. Right, index laws, just wanted to highlight a little difference here. So in this first case, the base is x, the coefficient is the 3 and the 4. So these aren't affected by the powers, so these do get multiplied in this case, which is 12x, and then we just add our two powers, 5 plus minus 3. Again, your calculator will do that for you. That's the power of 2. In this case, a common mistake we see is that students write 1 and then subtract the powers and get 9 minus 4, which is 13. That's not correct, because these are the bases, so the base doesn't change. So the difference here is that x was the base and you had a number before it. In this case, 7 is the base of your index, so therefore the 7 stays where it is, and it's 7 to the 13. So again, thinking about the third one, the base is p, the coefficient is 6. So therefore this negative 2 has to be done on both of those. So if we do the p part first, minus 3 times minus 2, because these two values get multiplied, that's positive 6. So we've got p to the power 6. And then if we do 6 to the minus 2, 6 to the power minus 2, again your calculator will do this for you, that's 1 over 36. So you can write this then as 1 over 36p to the power 6, or what's slightly better is p to the 6 over 36. Or you might convert that to a decimal, but it'll give you a recurring decimal, so just be careful with that one as well. Speed distance time again is a topic that we usually expect to appear in the papers, and there doesn't seem to have been much of it so far on paper 1 or 2. So this one says a runner completes a 10-kilometer race in 53 minutes and work out their average speed. So 10 kilometers in 53 minutes. Remember, speed is in kilometers per hour, so we want to go 60 minutes because we want to find out how much it takes. So our scale factor here is 60 over 53. And then getting our calculator and doing 53 over 60, 10 times 60 over 53, gives you an answer of 11.3 to 1 decimal place. So it's 11.3 kilometers. So therefore the speed is 11.3 kilometers per hour. It says the second runner completes the race at an average speed of 10.5 kilometers per hour, so a bit slower. How much longer does it take them to complete the race? Okay, well 10.5 kilometers per hour means 10.5 kilometers in 60 minutes. And I want to know, well, how long does it take them to do 10 kilometers? Again, our scale factor here is times 10 over 10.5. So therefore, if we multiply this by 10 over 10.5, we get 60 times 10 over 10.5. and that gives us an answer of 57.1. And then some more, so therefore to the nearest minute, 57 minutes. Now again, always go back and read the question, make sure you've answered it. It says how much longer does it take? Okay, well it takes 57 minus 53 minutes, so that gives us 4 minutes longer. Similar idea here, density, mass and volume. So it gives us the mass, it gives us the volume, asks the density, and it asks us to state our units. And that's really important because actually, if you can state your units, you'll remember the formula, but also that's worth 1 mark. So even if you can't do the calculation, you do get a mark for your units. So in this case, your density is kilograms, the mass per meters cubed divided by volume. So density is mass divided by volume, so therefore the density is equal to 3.8 divided by 4. If we put that in our calculator, it gives us 19 over 20 or 0.95. So our answer is 0.95 kilograms per meters cubed. And we're going to look at some basic algebra again. Again, just a quick reminder of each of these. So if we start by expanding our brackets, we get 15x cubed plus 21x squared y. Second one, expand each of the brackets separately. We get 14x minus 63. And then remember in this one we're multiplying it by negative 4. So that's negative 8x and then plus 44. If we then collect like terms, 14x take away 8x, that's 6x. And then minus 63 plus 44. And again, in this case, we shouldn't be making any calculation errors because you have a calculator to do this for you. Okay, and that gives you 6x minus 19. The next we need to factorize. So factorize means put into brackets. So 45 and 9 can both be divided by 9. And we can take an x squared out of both of those. And what you'll notice is that's the entire first term. Now the first term doesn't disappear. It's been multiplied by 1. So we get 1 minus, and then in the second term all we're left with is 5z. So be careful that we don't just get rid of this. It should be a 1 here. Okay, because 1 times 9x squared gives you 9x squared. If you put nothing there, then you completely eliminate the first term. So just be careful with that one. Solving equations. Remember, solve just means figure out the value of the variable or the unknown. In these cases, I've used x. So we have to figure out the value of x. So if we expand our brackets, we get 21x minus 28 is equal to 11. Then we add 28 to both sides. You get 21x is equal to 39. And then we divide both sides by 21. And we get x equals 39 over 21. Now it's fine to leave that as an improper fraction. However, the expectation is that you would simplify it. And again, you have a calculator to do that work for you. So that's 13 over 7. Which is tidier than a decimal, which gives you 1.857142 recurring, which obviously is a little bit more complex, so we can't just leave it as an improper fraction. Now with the one on the right, we've got unknowns on both sides. I like to always move the smaller x, so in this case we're going to move this 5x, so subtract 5x from both sides, and we get 8 is equal to 3x minus 13, and now it's pretty much the same as we had on the left hand side, we just have to work the other way around. So we add 13 to both sides. That gives us 21 is equal to 3x. Dividing both sides by 3, and this gives us a nice integer answer of 7. Okay, so sometimes you get a whole number answer, sometimes you get a decimal answer, and it's nice to finish with your x on the left hand side. So we finish with x equals 7, and we put that on our answer line. And again, this one was x equals 13 over 7. Now forming and solving equations can also be another way, and there's lots of different ways that this can appear. This is just another example. So it says work out the value of x. It's also assessing your knowledge of angles and parallel lines. So in this case, they're alternate angles, which means they're equal. So therefore we can just say that each of those angles is equal to one another. There's our equation formed, and therefore we can just do like we did in the last question, solving with for an unknown. So we take away 3x from both sides. You get 2x minus 46 equals 62. 2x equals 108 because we've added our 46 to both sides. So therefore x is equal to 54 degrees. So x is 54. Making x the subject, again, the simple ones tend to be not a problem with anybody. This one, where you've got two x's, tends to cause a little bit of confusion, so just a quick reminder of this. We start by, because we've got two x terms, that's what makes it a bit harder. So we start by getting rid of our denominator, so multiplying across by that, we get 5y plus xy is equal to the numerator, 3x minus 4p. Now we're going to group our x terms together. I'm going to move them to the left, so I get xy minus 3x, and then minus 5y minus 4p. I'm trying to make x the subject, so I'm going to factorize out x, and I get y minus 3, and the right hand side remains unchanged. And then my bracket just becomes my denominator, so I get minus 5y minus 4p over y minus 3. And that's our answer. That's our rearranged formula with making x the subject. And then equation of a line. Again, we've done quite a few of these, but again, just in this video, just a quick reminder of these. So we always use the same three steps. Step one, we're going to find m, the gradient. So remember, m is the change in y divided by the change in x. And that's an additive change. So what have I added or subtracted? So to get from 8 to 3, I've taken away 5. And to get from 5 to 15, I've added 10. So therefore that's minus a half. And again, your calculator will simplify that for you. So then we want to find c. So we're going to sub in one of our points. I like to use the smaller numbers. So we get y is equal to minus a half x plus c. Subbing in our value, then we get 8 is equal to minus a half times 5 plus c. 8 is equal to minus 5 over 2 plus c. And then we add 5 over 2 to both sides. Again, you have a calculator to make your life easier, or if you prefer to use decimals, you can do that too. And that gives you an answer of 21 over 2 or 10.5. Let's use 10.5 to make our life a little bit easier using decimals. So therefore our answer should be y is equal to minus 0.5x plus 10.5. We use decimals all the way through, or you could use minus a half. Same idea on the right hand side. Our step one is to find the gradient. Now in this case, we already know it's perpendicular, which means we use the negative reciprocal. So therefore m1, our current gradient, is 3. So our perpendicular gradient, which we'll call m2, is minus 1/3. And then it works out exactly the same way as we had on the left hand side. Y equals minus 1/3 of x plus c. Subbing in our point, we get minus 7 is equal to minus 1/3 times 15 plus c. Again, your calculator will do a third times 15 for you. You get minus 7 is equal to minus 5 plus c. So therefore c is equal to negative 2. So our final answer then is y equals minus 1/3 of x minus 2. And that's the equation of the perpendicular line. Now plotting graphs. Again, if this is a calculator topic, it works out really nicely because it's just substitution. So we're going to substitute each of our x values into our equation and figure out our y values. Okay, so if we sub this in, 2 to the power minus 2 is a quarter, 2 to the power minus 1 is a half, 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4. Now we shouldn't be making a mistake on this because we've got a calculator. So just use your calculator for everything. Even if you think you know the answer, double check it on your calculator. Now we can plot each of those points. So minus 2 and a quarter, well a quarter is there because each one of these seems to be worth a half. Minus 1 and a half, 0, 1, 1, 2, and 2, 4. And this is an exponential function. And then join your points exactly through where it needs to go. And that's what we end up with. Two things about an exponential function. So if you've got 2 to the power of x, one thing is it will always cross here. So it's always going to cross at 1 on the y-axis. And the second thing is it will never touch the x-axis. Because you can't do 2 to the power of something and get an answer of 0. Okay, so it'll never touch that. It'll get really close to it, but it will never touch it. Now, arithmetic sequences, just a quick reminder of these. Again, that just means we should have a common difference. So if we look here in each of these cases, we're just adding 7 every time. And then if we go back one step, so 43 take away 7, and that gives us 36, positive 36. So if our nth term is 7n plus 36. It asks us for the 114th term. That just means n equals 114. So we do 7 times 114 plus 36. And again, just put it in your calculator. It'll do the work for you. And that gives you 834. The last one then asks, is 288 a term in the sequence? Well, what we'll do is we'll do 7n plus 36 is equal to 288. And now we're going to solve that like we've done before. So 288 minus 36 gives us 252. And then dividing that by 7 gives us an answer of 36. And because that's a whole number, that means yes, it is in the sequence. Now the next question is a quadratic sequence. Again, you're just asked to find the nth term of the sequence, and the way that we know it's quadratic is if we look at that difference again, we can see, well, that one's 7, that one's 15. If we look here, again, subtracting those, that's 23. And then if we look at the next one, that gives us 31. Now if we look at the difference of the differences, we can see that's going up 8 every time. And because of that presence of a second difference, that's what tells us it's quadratic. Now with this then, the way I'd like to do this is I then take a step backwards. So this is 8, 7 take away 8 is -1. Then taking a step backwards, -3 take away -1 is -3 plus 1, which is -2. And using those three values, so this is kind of separate, these three values, we know that c is equal to this, a plus b is equal to that, and 2a is equal to this. So therefore, a, b, and c. So if 2a is 8, that means a is 4. And then 4 plus something gives me -1. Well, how do I get from 4 to -1? That's -5, or take away 5. And then c is just that -2 value. And remember, quadratics are in the form an squared plus bn plus c. So our final answer is 4n squared minus 5n minus 2. And that's our fully written nth term for our quadratic sequence. Now identities again are one of those topics that can be really straightforward, it can be really complex. Often if you just look at the question you can figure this out. You can see here that, okay, well 2x times ax is going to give us that first term of 8x squared. So because of that we can straight away tell, well, a must be 4. Okay, and then you can expand the brackets from there to work out b and c, which makes life a little bit easier, but you might be able to just spot that. However, what you can do is if you just evaluate this by expanding your brackets, I'm just going to show you a slightly different way to do it. It's 2ax squared plus 10x minus abx minus 5b is congruent, or is identical to 8x squared minus cx minus 30. Now we can then compare these things. So we've got an x squared term here and an x squared term here. So 2ax squared is equal to 8x squared. The x squareds cancel, so therefore if 2a is 8, a must be 4. That's our first value. If we then look at our x terms, so we've got these x terms here and we've got this x term here. So we've got 10x minus abx is equal to minus cx. Again, we can cancel our x's, but we've got a, b's and c's here, so we don't know enough information. We know what our a is, but we don't know what our b is. So we're going to pause that one for a moment, and we're going to move on to the third one. And the third one is going to be our -5b and our -30. So -5b is equal to -30. Dividing both sides by -5, we get b is equal to 6. And now because we know b and we know a, we can use that to help us with the middle one again. So therefore, a was 4, b was 6, so 6 times 4 is 24. So we get 10 minus 24 is equal to minus c. 10 take away 24 gives you minus 14 equals minus c. So therefore c is equal to positive 14. So a is 4, b is 6, and c is 14. Now, factorizing quadratics can come up in the middle of a question, or it can be as a standalone question. And again, it's just about refreshing our memory on that. So we start 4 times 10 is 40. Looking at our factors of 40, we get 1 times 40, 2 times 20, 4 times 10, and 5 times 8. Okay, I think that's all the factors that we need. So therefore we can then go, well, okay, how do we subtract them to make 3? Well, that's going to be 8 take away 5, because that will give us the 3 that we need. So we're going to use the 8 and the 5. So we get 4x plus 8 and 4x minus 5. Again, dividing this side by 4, because one needs to be divided by 4. That gives us x plus 2 and 4x minus 5. And that's it factorized. Then it says hence or otherwise solve the equation same quadratic equals 0. So therefore, because we've already factorized it, we may as well use the factorization method. And then we just do the inverse of what's in each bracket. So the opposite of plus 2 is minus 2. And then in this case, the opposite of minus 5 is plus 5, and then divided by 4. Now in this case, we're also solving a quadratic, but there's a big hint in this, and that's to 2 decimal places. And if you're asked to give it to 2 decimal places, that reminds you, okay, we must be using the quadratic formula. And remember that quadratic formula appears on your formula sheet. So if we rearrange this, we get 3x squared, because again, remember, your quadratics must equal 0. 18 take away 5 is plus 13x, and then negative 17 take away 3 is negative 20 equals 0. So therefore, a is 3, b is 13, c is minus 20. Remember to bring that minus with you. So quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. And again, that's in the top right hand corner of your formula sheet. When we sub in, again, into brackets, we should put all our values. Square root of 13 squared minus 4 times a times c all over 2a. And again, we're going to do this calculation twice. And the reason we're going to do it twice is because of this plus or minus. So we're going to do it once with a plus and once with a minus. So again, common mistake that people make, or a common frustration, is when you're doing this, remember to press your fraction button first, because that way you won't have, because if you don't, you then can't put all the numerator onto the top of the fraction. You'll have to start again, which can be a little bit frustrating when you're tight on time in an exam situation. So the two values we end up with then to 2 decimal places is 1.20, and then if you just use the little arrows to navigate and just change that plus to a minus, minus 5.54. Again, you are expected to round that correctly because it's rounded to 2 decimal places, not truncated. So it gives you 5.537 or 5.54. And again, that's our answer to 2 decimal places. Simplifying algebraic fractions. Again, this is what I was talking about earlier about how your quadratic can be mixed into another question. So the top one is the difference of 2 squares. So that becomes 4x minus 7 and 4x plus 7. And then we can just factorize the bottom like we did before. And again, I'll save us some time. Factorize the bottom for us, which gives us x minus 5 and 4x plus 7. And we can see then these two brackets just match. So our final answer is 4x minus 7 over x minus 5. And that's because we were asked to simplify this. There's no solution, it's just a simplified fraction. We can also be asked to solve algebraic fractions. So in this case, we need to make them have the same denominator. So therefore we have just the two denominators combined together. And then we cross multiply each of those values. Now this minus often causes people a problem because they don't know what gets multiplied with the minus. What I like to do is I change this to a plus and then put the minus with the 5 instead. Okay, and that just makes it less likely that we'll make a mistake. So multiplying 3 by the bottom right denominator, we get 6x minus 21. And then now we're multiplying negative 5 by the denominator on the left hand fraction, which is minus 5x minus 15. Which means that that's where you're less likely to make that mistake. Collecting like terms on top, you end up with x minus 36 is equal to 4, and then again that's over, and then if we expand those brackets, 2x squared, and then you get minus x minus 21. Again, solving that now by bringing across that, you get x minus 36 is equal to 8x squared, because we're multiplying by 4, minus 4x minus 84. And because we've got a quadratic, we want it to equal 0. So therefore, by rearranging that, I put it over here, we get 8x squared minus 5x. And again, because we're subtracting negative 36 or adding 36, we got minus 83 plus 36. That gives us minus 48 equals 0. Now again, we can check if it factorizes, but just to save ourselves some time, we can just use the quadratic formula all the time. And if we use the quadratic formula, we get an answer of x equals 2.78 and x equals minus 2.16. Again, we just use the quadratic formula, and just to save us time and space here, that's what we would get. And if you want to remember how to use that, just go back and look at the clip from a few moments ago. Algebraic proof is always a nice one. So we just need to be able to represent consecutive numbers, odd numbers, even numbers. Even numbers are again your 2n, 2n plus 2, 2n plus 4. Odd numbers, 2n plus 1, 2n minus 1, 2n plus 3, etc. And then consecutive numbers are n, n plus 1, n plus 2. So I want two consecutive odd numbers. So that's going to be, now what I like to use for this is 2n minus 1 and 2n plus 1. They tend to work out as a nicer proof for you. Now I want the product of those, which means I want to multiply these two things by each other. So if I expand those brackets, I get 4n squared plus 2n minus 2n minus 1. And then collecting like terms, I get 4n squared minus 2n plus 2n. Well, they cancel each other out, and you get minus 1. The question asks us to prove that it's always one more than a multiple of 4. Well, this is a multiple of 4, and this one is one less than a multiple of 4, like it asked us for. So therefore, it's always one less than a multiple of 4. Simultaneous linear equations, we need to make one of the variables the same. I like to use the ones that have a positive and a negative value, so I'm actually going to make the y's the same in this case. So I'm going to multiply the first line by 7 and the second line by 4 to make that middle number 28 in both of those cases. That gives us 21x plus 28y is equal to 77, and we get 8x minus 28y is equal to, now 17 times 4, again, you have your calculator, so don't be afraid to pick it up. 17 times 4 gives you 68. And now, because they're different signs, I'm going to add these two lines together. So that gives us 29x is equal to 77 plus your 68, which gives you 145. And then we get x is equal to, by dividing by 29, x is equal to 5. Now we take that x value and we substitute it into it. I'm going to use the first one. So we get 3 times 5 plus 4y is equal to 11. That gives us 15 plus 4y equals 11. Solving that then gives you 4y equals negative 4. So y equals negative 1. And there are two answers. And the way you can check this, you don't necessarily need to write this down, but a nice check is to sub both values into the second equation. 2 times 5 minus 7 times minus 1 gives you, if you put that in your calculator, gives you 17, which is the answer you wanted from here. So therefore, you can be fairly confident that your answer is correct. Now we can also get nonlinear simultaneous equations, and it asks you to give your answer to one decimal place, which implies then that when we get that quadratic, we're going to have to use the quadratic formula. So we're going to use a substitution method. So y equals 2x minus 1. So this 2x minus 1 is going to be subbed in for y. So we get x squared plus 2x minus 1 squared equals 15. Be very careful that you don't forget this, because that's often something that students forget and then they end up not being able to do the question. So that x squared plus, expanding your brackets, 4x squared minus 4x plus 1 equals 15. And again, because we've got a quadratic, we need it to equal 0. So we've got 5x squared minus 4x minus 14 is equal to 0. And again, like we've seen before, we're just going to use our quadratic formula here to work out the values of x, because it says to one decimal place. So using our quadratic formula, we get answers of x equals 2.1 and x equals minus 1.3. And then to get our y values, we're going to substitute each of those values into our first equation. So again, in this case, again, I'm going to write it in green because you don't have to write this in the exam. We get y equals 2 times 2.1 minus 1, and in this case y equals 2 times minus 1.3 minus 1. And the answers we get in each of those cases are y equals 3.2 and y equals negative 3.6 as our final answer. Okay, the next topic we're going to look at is functions. And in this case, we've got g of 3.7. That just means we're going to substitute 3.7 in for x in g of x. So we get 2 times 3.7 squared, which when you work that out is 27.38. Now the other two are algebraic, so it says g of f of x. That means we're going to substitute f into g. So we're going to take all of this and we're going to substitute it in there for x. So we get 2 times 11x plus 9 squared. Let's square the bracket first. We get 2 times 121x squared plus 198x plus 81. And then multiplying all of those by 2, you get 242x squared plus 396 plus 162. And that's your final answer for g of f of x. The final one we want is f inverse of x. So if we look at f of x, well, what's happening to x when we do f of x? We're multiplying by 11 and then we're adding 9. So the inverse function does the opposite in reverse order. So we're first subtracting 9 and then dividing by 11. So therefore f inverse of x is x minus 7 all divided by 11. And that's your inverse function for f of x. The next topic is iteration, and in this we want to identify where xn is. And we're going to substitute our x0 value into that iterative formula. So therefore we're going to start with x1. So x1 is or x0 I should say, is the given value of 9. x1 is when you substitute in that 9. So you get the cubed root of 18 minus 2 times 9. That gives you 0. For x2, what you're going to write in your calculator, but you don't need to write this on the sheet, is the cubed root of 18 minus 2 times answer. And then your calculator will work out all these subsequent values for you. So when you do the first one, you get 2.62. And again, we're working to 2 decimal places here. x3, we just press equals again, and we get 2.34. x4 gives you 2.37. x5 gives you 2.37. And that's what we're looking for. We're looking for two values that are the same in a row. So therefore our approximate solution for x is 2.37. And that's the answer. So we want that repeated value. And once we get 2 consecutive repeated values, we know we've reached our answer. So the next question is proportion equations. And we're told that a is directly proportional to the cube of b. Well, the cube of b means b cubed. And we're told directly proportional is equal to k times whatever that other thing is. So we start by our standard form, which is a equals k b cubed. We can then sub in our values for a and b. 64 is equal to k times 6 cubed. 64 equals, and then 6 cubed is 216, so that's 216k. So therefore k is equal to 64 divided by 216, which gives us 8 over 27. So our equation then is a equals 8 over 27 b cubed. And that's our final equation. Next we're going to look at some trigonometry, so some Pythagoras, some SOHCAHTOA, and then the non-right angle triangles. So starting with right angle triangles, we've got Pythagoras theorem here, and we're trying to find the missing sides. And in this case, we're finding one of the shorter sides. So very quickly, we do the big number squared minus the smaller value squared, and then we square root all of that. And that gives us an answer of 7.657, or 7.7 to 1 decimal place. The second question asks us to find the value of x, but in this case we're only given one side and an angle. So we're going to use our trigonometric ratios. So we start by labeling our triangle. This is our hypotenuse, this is our opposite, and this is our adjacent. And using SOHCAHTOA, we can see we're going to use the opposite and adjacent, so we're going to use tan. Okay, so we've got tan of the angle, 53, is equal to the opposite, 8.1, over the adjacent x. Now remember, when the x is on the bottom, the unknown, you just swap the x with the tan. So we get 8.1 over tan 53. And that gives us an answer of 8.1 over tan 53. And we get 6.1 as our answer to 1 decimal place. Okay, which makes sense. Now if we go on to our sine rule, we can get most of our marks here without even using our calculator, because it's just about setting it up. Now the sine rule is given in the formula sheet. It's given as a over sine A equals b over sine B equals c over sine C. But remember, you can flip that over too. Now what I like to do is always put my unknown value in the top left position of my two fractions. So I've got x over sine 61, because my angles are always attached to the sine, is equal to, and then my other fraction is 5.2 over sine 53. Then, because my x is in this position, I can just move my sine 61 across and I get x equals 5.2 over sine 53 multiplied by sine 61. And then I can just put all of that into my calculator and get my answer. So 5.2 over sine of 53 multiplied by sine of 61. And that gives me an answer of 5.694, we'll say 5.7 centimeters. Okay, now we would expect it to be slightly bigger because 61 is bigger than 53, so we would expect x to be slightly bigger than 5.2. In this sense, we're asked to find an angle, but we're going to use the same sort of idea. Now remember, our angles are attached to sine, so in our top left position we put our unknown, and then that's over 11.4, and then we've got sine of 48 over 9.7. Again, we can just bring our 11.4 over and multiply, so we get sine x is equal to sine of 48 over 9.7 multiplied by 11.4. Now the last step, because we're finding an angle, to get x on its own, we do sine inverse. So we have x is equal to sine inverse of sine 48 over 9.7 times 11.4. And we can put all of that into our calculator in one go. And again, this is why it's important to always use your own calculator and be comfortable with what your calculator can do, because it just makes these calculations that little bit quicker for you. So times 11.4, and that gives us our final answer of 60.85 or 61 degrees. So that's how we do the sine rule. Okay, in this next question, we're going to look at how to use the cosine rule to find a missing value. So we use the cosine rule when the sine rule doesn't work, and the sine rule works when we've got a pair. In this case, we haven't got a pair. So this is a prime example of when we use the cosine rule. So the thing we have to remember with the cosine rule is capital A is the angle, lowercase a is the side opposite, and then B and C, doesn't really matter which way around you do them. So the cosine rule is given to you in the formula sheet. So you get a squared equals b squared plus c squared minus 2bc cos a. So we get x squared is equal to 7.1 squared plus 10.3 squared minus 2 times 7.1 times 10.3 times the cosine of 83. And then we're just going to work that out in our calculator and then the square root of it all. So we end up with an answer of 11.8 as your value of x. Now when you're trying to find the angle, we can do that slightly differently. This formula isn't given, but it's a rearrangement of the other formula, and it just makes it slightly easier. So cos A is equal to b squared plus c squared minus a squared over 2bc. Once we sub into that formula and then find cos inverse of it, we end up with a is equal to cos inverse of 8.6 squared plus 5.8 squared minus 12.3 squared all over 2 times 8.6 times 5.8. And then in your calculator, that gives you an answer of 115.97 or 116 degrees. So we can say that's 116 degrees. And final trigonometry question, area of a triangle. And again, this formula is given to you. The area is equal to a half AB sine C. So therefore the area is equal to a half times 7.1 times 10.3 times the sine of 83. So there's no cosine rule for the area, it's just always sine. So therefore the area is equal to, putting all that into your calculator, you get 36.3 centimeters squared. And that's how you find the area. And the key thing to remember is that C, the angle, is between the two sides. The next topic we're doing is area and circumference of parts of circles. Now you're given the formula for the full circumference and the full area of a circle. We just have to figure out how much of the circle we have. Now in this example we've got 264 degrees. So very simply for the area we just do 264 out of a full circle, which is 360, and then multiply by your normal area formula, which is pi times the radius squared, which in this case gives us pi times 6.4 squared, and that gives us an answer of 99.4 centimeters squared. Now the perimeter you just need to be a little bit careful with. So for the perimeter, you've got 264 over 360, times your circumference, so pi times the diameter, and the diameter in this case is double the radius, so 12.8, and that gives you 29.5 centimeters. Now that's what we call the arc length. That's the curved part. So what we need to do for the perimeter is 29.5 plus 2 of your 6.4s. And that gives you an answer of 42.3 centimeters. And that's your perimeter. So with your perimeter, remember to add on the 2 radii. So you've got those true straight edge parts, because the angle over 360 only gives you the curved part. Okay, next, just a quick reminder of volume and surface area and the formula we have for them. So the volume of a prism, this is given, the formula, and it's the area of the cross section multiplied by the length. Okay, so area of the cross section times length, and that's given to you. A cylinder is not given, but it's just a prism with a circle for the cross section. So this is their circle pi r squared times the height or the length. So it's the same as a prism, you can just do that. For a pyramid or a cone, it's 1/3 times the base area times the height. Okay, a cone is slightly different, but it's the same thing. It's 1/3, because the base area is a circle, pi r squared h. And then finally a sphere is 4/3 pi r cubed. Now for these two, these are given in the question. So in the actual question, they will give you those formulae. They're not in your formula sheet, but they will give them to you in your question. The curved surface area doesn't apply to a prism because it usually doesn't have a curved part. For a cylinder, it's the circumference of a circle, so pi times diameter, and then times that by the height. That will give you the curved surface area, or 2 pi r h is another way that you'll see that. In this case, it's just for a cone, and again, this is given. So it's pi times the radius times the length, where the length is the slant height, so it's from the point to the circumference of the base. And then a sphere is 4 pi r squared. And again, these last two are given in the question. And this is not given. And then finally, there's a last one you can do. So these total surface area. So this is the surface area of the whole shape. What you can do is you can find all the faces individually and add them all up. Or for a prism and a cylinder, because they're pretty much the same thing, you can do the 2 times the area, that's the cross-sectional area, plus the perimeter times the length, which essentially is the curved surface area plus the 2 ends. And that works in both of these cases. And if you can work both of those out, that allows you just to do the total surface area quickly. The other way is work out each face separately and then add them all up. For a pyramid or a cone, same thing, you just add up all the faces. But for a cone, you would do the curved area, so curved surface area plus the base area. And a sphere, it doesn't matter because it's the same thing as a curved surface area. There's no flat faces on a sphere. So that's what we would have. But just remember that those prisms and cylinders are the ones we need to be comfortable with, because they're the formula that you're not given, where pyramids, cones, spheres you're usually given, which makes life a little bit easier. And also remember, on your formula sheet you have got a prism, which is the area of the cross section times the length. Okay, and then a cylinder is just a circle times the length, and you have the area of a circle. So a lot of it is there already given to you. Quick reminder of your angle facts. This is angles in a straight line. So this is a straight line. And they add to 180. Now the important thing here, and this is a misconception of, it's across this. So it's where this point happens. That's only, it doesn't matter if there's another one over here. This has nothing to do with the one that we have. So that's completely separate. So it's just here where all these lines meet, and that's 180. The next one, if you've got these X shape, these are vertically opposite or just opposite. And they are equal. These are around a point. So angles around a point or at a point add to 360. And finally, a triangle is 180 A quadrilateral or a four-sided shape is 360. They all have to give you. Okay, so any three-sided shape is 180, any four-sided shape is 360. Parallel lines, there's two rules you need to remember about the angle facts here. Well, there's three rules, but there's two things you need to remember. There's only two angles. There's a big angle and a small angle. So if this big angle here is, let's say, 130, then this big angle is also 130, and this big angle is also 130, and this big angle is also 130. And then all the small angles, well, they make straight lines with the other ones, so they're all 50s because they add to 180. So with one angle, you can work out every angle in that question. Then we just need to remember the rules. So the name of the rules are corresponding, which means same position. Now what I mean by that is if we imagine that split into two halves, this top left, so this 130 here is the same as this top left. This top right is the same as this top right. So that's what corresponding means. If we have alternate angles, they're in the opposite position. Which is, for example, this one here and this one here, because that's bottom left, this is top right, so they're in the opposite position, and again they're equal. And then finally, the last one we have is co-interior angles. Okay, so let's do this in the blue. So co-interior are equal. Or sorry, they're not equal. Co-interior sum to 180. And that's because they're both inside angles. So these two are co-interior. So it's just about remembering, you can work out all the numbers. If you can't remember the rules, at least you can work out the numbers and get some marks from there. Now very simply, we've got polygons next, and polygons, we've got regular and irregular polygons. The only difference is that regular polygons, all the angles are equal and all the sides are the same length. Irregular, they're not. There's three rules we need to have. There's the sum of the interior angles, and that's n minus 2 times 180, where n is the number of sides. The second one you've got is an exterior angle. This is for regular only. It's always 360 divided by n, n always being the number of sides. And then finally the interior plus the exterior is equal to 180, because it's remembering that an exterior angle is not the outside, it's what joins the interior one to make a straight line. So this is interior and this is exterior. And that should be enough. You can remember those formulae because they're not given. If you remember those formulae, you should be able to work out any of those questions around angles and polygons. Vectors again is another good topic, and there's lots of different things you can be asked on this, but let's just look at this question. So it tells us that AB, so we're going to add these arrows on, so A to B, so that's coming down. That's going to be 3A, and then B to C is 2B. So we've got both of those in there. It says ED, so E to D is minus 3A plus 2B. Then it tells us about the ratio of B to C is 4 parts and C to D is 7 parts. Well, we know that B to C is 2B, so therefore we can see, well, what's our scale factor here? It's a half B, because it's a half of this, and then we multiply by, we stick a B on there as well. So we times this by a half B, we end up with 3.5B. Now, I prefer to use fractions. It just makes life a little bit easier when we're simplifying. But again, because you have a calculator, you can use decimals. So that means that CD is 7 over 2B. And I like to go through this and fill in as many as I can as I go along. And then finally, so this is BF is 2/5 of BE. Okay, so let's work out BE first. So to get from B to E, I'm going to go B to D, and then I'm going to go D to E. So that's going to be 2B plus 7 over 2B plus 3a minus 2b. Because we're going against the arrow here, we change both these signs, so it becomes a plus 3a and a minus 2b. If we collect our like terms, then be will be equal to, I like my a's to be first, so 3a plus 7 over 2b, because 2b minus 2b is 0, plus your 7 over 2b is 7 over 2b. That's b to e. Now I want b to f, which is 2/5 of that. So b to f is equal to 2/5 of 3a plus 7 over 2b, and then multiplying by a fraction just gives us 6 over 5a plus 10 over, doesn't give us 10, apologies, 14 over 10. So it's 14 over 10b, okay, which we can then simplify to 7 over 5. So that will give us 6 over 5a plus 7 over 5b. Now if you want, some people would like to tidy this up and they'll say, well, that's the same as 1/5 of 6a plus 7b, but either of those two answers is acceptable. The other thing you might be asked is, does something make a straight line, or are they parallel? Now if they're parallel, or if they make a straight line, it's the same thing. You just want to show that they're parallel to each other. And to show that they're parallel, what you do is similar to what I just did there by factorizing out the 1/5. You factorize out so that what's left inside the brackets is exactly the same. And if inside the bracket is the same, no matter what scale factor is on the outside, that means the two of them will be parallel to each other. Now, last couple of questions here, we're going to look at commutative frequency. Remember, commutative frequency just means running total. So we're going to work out a running total here and add these up as we go along. So you have 6, 18, 42, 64, 74, and 80. Now we need to label our axes here. So if we look, double check that, 10, 20, 30, 40, 50, and 60. That works nicely for us. And again, it's worth checking just to make sure this works. And then going up, we'll save ourselves some time. We'll do 20, 40, 60, 80. And we just want to make sure that's a consistent scale. And then we're going to plot our commutative frequency with our upper bounds, our higher numbers. And our graph is going to start at 0 because 0 is our first value here. So we then go 10 up to 6, which is there. 20 up to 18, which is there, because every little box is worth 2 for us. 30 up to 42. 40 up to 64, 50 up to 74, and then 60 up to 80. And then we join these with a nice smooth curve. Being really careful that we go through all of our points exactly. The tolerance you're allowed is half of one of those little small boxes. So we need to be really careful. And because there's a mark going for this line, we want to take our time and make sure that we can take up to a minute to do that. Okay, and that's our graph drawn. It then asks for the median, which is the middle. Now that's the 40th person. And then the interquartile range is the lower quartile and the upper quartile. So 80 divided by 4 is the 20th person for the lower quartile, and then the 60th person for the upper quartile. So that's lower quartile and upper quartile. So if we go to 40, we come across to our graph. And again, it's better to use a ruler so it's nice and neat. And that gives us a median of 39. So the median in this case is 39. The lower quartile, again, 20 over to our axis and down. I would say that's 21, 22, so we'll go with 22 here. So say the lower quartile is 22. And again, yours will be drawn much neater because obviously you'll use a ruler. And that comes across to there, which will come down to here. And that's going to give us 37. So the upper quartile is 37. And I've just noticed I've made a misread here, and that's a good thing to spot. Okay, I've made my median, I've misread, should have been 29, not 39. Our interquartile range then is the upper quartile minus the lower quartile, so 37 minus 22, which gives us 15. And that's our interquartile range. Now, histograms, again, the key thing with a histogram is that the area of the bar is equal to the frequency. Okay, so we're told that 20 people complete the run in the first section, so this frequency is 20. And because we know the gap is 10, we know that our class width is 5. Sorry, our gap is 5. And we know our frequency density then is 20 divided by 5, which is 4. Okay, that means the height of this bar is 4. Okay, so if we look carefully, then we can figure out, well, what does each of those little boxes represent? Well, it means that every tiny box represents 0.5, because I know that's 4. So therefore that's 5, 10, 15, 20. So we can have that nice and neat as we go along, because as I said, there's 8 little boxes and the height is 4, so therefore every 2 boxes is worth 1. So therefore that's 5, 10, 15, 20, and now we can work out what we need from here. So the next bar, that's 5, up 2 boxes 6, up 2 boxes 7, up 2 boxes 8. So this is 8 times 10, so that represents 80 people. This is 10, 11, 12, 12.5 times 10 people, which is 125. So we've got 80, 125. This one is 15, so that's 16 of a height times our gap, which is 20. 16 times 20 is 320. And then the last box then goes up to 2, 4, 6 boxes. That's 3 times 15, which is 45. Okay, then when we add all those values, we can fill all those into our table. So 320 and 45, and that gives us our table complete. Okay, last one, looking at averages for raw data. So the mode here, again, the mode is the most common, and the only number that repeats itself is 24.6. So that's our mode. Our median is our middle value. Now luckily our data is already in order for us, but because we've got 8 values, we actually need to find the middle value in here. So it's what's halfway between those two. Well, the way we find halfway between those is we do 18.6 plus 15.3 divided by 2. So 18.6 plus 15.3 divided by 2 gives us an answer of 16.95. So the median is 16.95. The mean is the one that everyone always remembers. You add them up and you divide by how many you have. So you add all those numbers together and you get 140.2 divided by 8 gives you 17.525. And then finally the range is the biggest minus the smallest, so 28.9 minus 6.4, and that gives you 22.5. And that's your range for the data. And again, it's just about remembering what each of those words mean, and it'll make life a little bit easier for you. Now this question is estimating the mean or finding data from a frequency table. So very simply, the modal class interval is the one with the highest frequency. So we want to find the box that has the most highest frequency, which is this, and the class interval then is this one. So it's 2 less than h less than or equal to 3, and that's your modal class interval. Your median class interval means you want to find the middle person, so we need to know how many people there are in total. So we're going to use our cumulative frequency here. Now I like to write that over here in this case because we're doing both this and estimating the mean, so I don't want to confuse things. So here we've got 8, and then 8 plus 17 gives us our 25, 45, 51, and 56. So we can see we've got 56 people in total. So I need to find halfway. So half of 56 is 28. So we want to find the 28th person. Well, if we work through this box, 28 is here between 25 and 45. So therefore, again, the median here should be, or the median class interval, is the same as the modal class interval. So it's 2 is less than h, it's less than or equal to 3. Estimating the mean, however, is slightly different. Now, the reason we're estimating the mean is because if we look at this 20 again, that means 20 people are somewhere between 2 and 3 meters in height. Okay, so what we want to do is tidy this up, and we're going to estimate it as the midpoints. So this becomes 0.5, 1.5, 2.5, 3.5. Now be careful on this last one because we sometimes get caught in the habit of following that pattern. The next one should be 4.5, but the interval size has changed, and actually the middle point here is 5. So be very careful with that, that doesn't change as you go along. And then the last one you find is your midpoint times your frequency. So you're times your 8 times your 0.5, 17 times 1.5, etc. So that gives you 4, 25.5, 50, 21, and 25. When you add all those values together, you get 125.5. And we know that our frequencies give us 56. So we're doing 125.5 divided by 56. And that gives us 2.24 as the mean height. And that makes sense because it's between 0 and 6, and we'd expect it to be roughly in the middle. And a lot of the data is here between 1 and 3 meters, so we're happy with that. Okay, this frequency tree. So we're told 120 students are chosen, so that's 120 in here, are surveyed. We're then told 60% attend a sports club. So 60% of 240 is 144. So that means we've got 144 in here. And then 240 minus 144 gives you 96 for did not attend. It then says of those who attended, 5/8 are boys, so we can just do 5/8 times 144, and that gives us 90. So therefore there's 90 boys and there's 54 girls. We're then told there's 135 girls surveyed in total. Well, if we do 135, take away the 54 girls that we already have, that tells us there's 81 girls left. And then finally, 96, take away your 81, gives you your 15 for your boys. The follow-up questions then are usually something to do with probability. So it says a person is chosen at random. That means it's any of the 240 people. So your denominator is 240. Work out the probability they attend a sports club. Well, that's just this box here. So it's 144. And remember, there's no need to simplify probabilities. The next one says a girl is chosen at random. Now we know there's 135 girls because A, we're told that, but B, we can just add these two values together. And then it says work out the probability they do not attend a sports club. Well, do not attend girls are these 81 on the bottom. So it's 81 over 135 as your answer on that one. Okay, and the final topic we're going to look at is tree diagrams. And again, this is just a very simple tree diagram question, but it's got that conditional element where it varies between the two questions, or between the two events. So the probability of a drink is 0.65. We're told that in our table. We're told that if they get a drink, the probability that they get a cake is 0.4. And if they don't get a drink, the probability they get a cake is 0.25. Now we remember that each set of these branches add to give 1. So I just have to do 1 minus 0.65 to give me 0.35. 1 minus 0.4, which is 0.6. And 1 minus 0.25 is 0.75. Now what I like to do is then at the end fill in all the information. So I've got drink and cake, drink and no cake, no drink and cake, and no drink and no cake. And to work out each of those probabilities, you just multiply along the branches, which gives you 0.26, 0.39, 0.0875, and 0.2625. And it says work out the probability that a random customer buys a cake. Well, these people buy cakes and these people buy cakes. So I'm going to do 0.26 plus 0.0875, which gives me an answer of 0.3475. And that concludes our last topic. As with the other two videos, just some final tips. First of all, show all you're working out. It's very tempting just to put in your calculator and write down the answer you get. But whatever you type into your calculator, just write that onto the page, and it just shows, even if you miscopy from your calculator, you show that you had the right intent and you'll get some marks on that. Make sure you answer, when you answer, you read the question again and make sure you get the answer that was asked. Okay, because what you want is, if the question asked you, is this enough or which one is better, and you've just put a number, you want to actually make that decision. So make sure you've answered the question that has been asked of you. Complete parts of the question. So if there's a ratio, the fraction, a percentage part of the question, you'll get some marks. We've covered those in this video, so just you can cover those particular topics to help get you some marks, even if you can't get to the final answer. Draw your diagrams in pencil. Okay, if you misdraw your commutative frequency or your histogram or whatever diagram you're drawing, it's so much easier if you can just rub it out with a pencil, rubber, and start again. Okay, but you can't do that if you use a pen. Okay, so make sure you're using a pencil for your diagrams. Attempt every question. Okay, there's no optional content. You might get a mark, you might just guess, you might get lucky. Obviously try and do that. And then finally, annotate your diagrams, because that work will be marked. Okay, any writing you have on there will get you some marks. Even if you're just thinking and you're trying to put some work on there and you go, I don't know, move on, there might be one or two things you've written on there that gets you a mark. As always, I hope you found this video really useful, and the best of luck in your final paper 3, and I hope you get the grade that you're looking for.